Fine students, today we are going to start our discussion about this will be your third video of the chapter chemical classification of elements and periodicity in their properties, and our today's point of discussion is electronegativity. Before this, in previous two lectures we have already discussed about the introduction and different laws which or different attempts which try to give you the classification of elements. Then we have discussed the long form of the periodic table blocks, and after that we were discussing the periodic trends in the properties. Out of the periodic trends in the properties, we have already discussed about atomic radius, ionic radius, ionization enthalpy, and electron gain enthalpy. This is the time when we are going to discuss about the electronegativity, right? So students, electronegativity is the capacity of an element to attract the shared pair of electron towards its center. What I'm saying, electronegativity is the capacity of an element to attract the shared pair of electron towards its center, right? For example, you are having two elements, element A and element B, or one atom of element A and one atom of element B. These two are forming, suppose, a covalent bond. You all know that by class 10th basics that a covalent bond is always formed by the sharing of two electrons, out of which one electron originally belongs to atom A and other electron originally belongs to the atom B, right? So technically a covalent bond says that this electron pair should be equidistant from both the nuclei of the atoms A and atom B, right? But what will happen if atom B is more electronegative, right? Because no two atoms in the periodic table have same, no two elements in the periodic table have same electronegativity values, right? So either this bond is between two same atoms like A and A, or B and B, right? In that condition, so I can say that the shared pair of electron is just in the between of two nucleus, right? Two nuclei. The same is the case when two A atoms are combining, but if one A and one B atom are combining, then any one of them must have more electronegativity than the other. So let's consider that the electronegativity of atom B is greater than that of atom A. Then what will happen? This shared pair of electron this shared pair of electron will be attracted by the atom B towards its center, right? Why? Because B is more electronegative. As a result, B will get some partial negative charge over it. Why I'm saying partial? Because this will not be a complete transfer of electron as in case of ionic bonds. It will be just slight shifting of ionic electron pair, right? So they will get partial negative charge and atom A will get partial positive charge, okay? And this arrangement is called dipole. What is dipole? I'll explain you in detail in chapter chemical bonding, but for time being you can understand that dipole is an arrangement in which two equal and opposite charges are separated by a small distance, okay? So two equal, because whatever will be the magnitude of the partial positive charge, the same will be the magnitude of the partial negative charge over B atom. Clear? So I hope now you are getting the idea of the electronegativity. What is electronegativity? Once again listen. It is the tendency of an atom to attract the shared pair of electron towards its center. All right. The most electronegative element in the periodic table is fluorine. Okay. Now let's discuss it in detail. This was a short introduction about your electronegativity. See beta, a qualitative measure of ability to attract, ability of an atom in a chemical compound to attract the shared electron to itself is called electronegativity. Why I am saying that it is a qualitative measure? Because we are not measuring it in some quantity, right? We don't know how much tendency of an atom is having to attract the shared pair of electron. We don't have any unit for this. That's why it is a qualitative measure. And this is why when we are expressing the electronegativity, some of you may ask, that's in previous classes or by default by your own study, you must know that the electronegativity of fluorine atom is 4, right? So what 4? 4 kilogram, for quintal, okay? Any unit is not there. Why we are giving this number to as 4? Because beta, Pauling was a scientist which also found this problem, okay? Because all the atoms are having this tendency to attract the shared pair of electron, all right? This was observed, but at the same time, it was also observed that we do not have any unit to express. We do not have any quantitative analysis of the electronegativities, right? So what does Pauling does? Pauling scale उन्होंने बनाया, okay? And according to Pauling scale, arbitrarily we have given the value 4 to the electronegativity of fluorine, right? Arbitrarily हमने 4 वैल्यू दे दिया फ्लोरीन को, और बाकी सारे एलिमेंट्स are given the value of electronegativity as means with respect to fluorine, okay? This is the most electronegativity, it is negative element, it is having electronegativity 4 in Pauling scale, okay? Some other scales are also there, but we need not to. Mulliken scale is there, for example, Mulliken-Jaffe scale, okay? Aldred-Rochambeau scale, right? But it's not necessary for us to study all these scales, okay? So this time, and for your class 11th and 12th studies, we will just go for electronegativity in Pauling scale, right? So वहां पर हमने fluorine atom को arbitrarily एक value दे दिया 4, and other all atoms are given or assigned with the values, numerical values for their electronegativity with respect to the fluorine. Clear? Attract shared electron to the itself is called electronegativity, and unlike ionization enthalpy or electron gain enthalpy, it is not a measurable quantity. Just now we have discussed this. However, a number of numerical scales of electronegativity elements, that is your Pauling scale, Mulliken-Jaffe scale, Aldred-Rochambeau scale, have been developed. The one which is the most popular, the most important for you is nothing but Pauling scale. Yeah, the most widely used is Pauling scale. Linus Pauling, an American scientist in 1922, assigned arbitrarily value 4 to fluorine, okay? The element considered to have the greatest ability to attract the electrons. Approximate value for the electronegativity of a few elements are given in the table or in your periodic table. If you people are having, if you don't have, it's my suggestion, just invest 10 to 15 rupees, purchase a periodic table from the market and fix it on your study table or near your study room, or okay, on your table or on a wall. So with the time you will get familiar with all the elements. Fine. So it is the electronegativity of any element is not constant. It varies depending on the, please highlight this point, because many of the students are after even doing class 12th, right? After class 12th board exams, they are having this doubt that if the electronegativity of any element is constant. No, but it is not constant. It varies depending upon the element to which it is bound, right? Electronegativity is variable. अगर आप positive charge increase कर रहे हैं, electronegativity will increase. अगर आप negative charge increase कर रहे हैं, electronegativity will decrease, right? आ रही है मेरी बात समझ में? So, for example, by electronegativity, just now I have told you that ability to attract the electron. Now just take an example. Suppose we are having elements. Wait a minute. So see students, for example, you are having element A, which is having say some electronegativity 2.5, okay? And it is attached with element B through a covalent bond, and B is having electronegativity 4, say B is fluorine, okay? So B will attract the shared pair of electron towards its center, and B will get partial negative charge, A will get partial positive charge. If at the same time, because A is having valency more than 1, then A is attached to H. Okay? Or instead of giving any particular element, let me take just examples. Hypothetical example. Attached to some hypothetical element C atom. Okay? And C is having electronegativity, say 2 only, right? But as soon as B is attached, yani electronegativity 4 element is attached to the element A, and A is getting partial positive charge, its electronegativity will be increased. Electronegativity of element A will be increased. Why? Because it is having positive charge. Now it has affinity for the negative charge, that is electron. Getting me? Clear? So electronegativity is not a fixed value. It is not a constant value. It varies depending upon the element to which the atom is bounded. Though it is not measurable quantity, it does provide a means of predicting the nature of force that upholds pair of atoms together, a relationship that you will explore later. Okay? In chemical bonding, we will discuss it in great detail, but for time being, you must have an idea of the electronegativity, right? In general, when element is not attached to any other atom, atom of any element is not attached to any other atom, right? Because this time we are studying the periodic table, we are not studying the chemical bonding. Okay, so this time we are just concerned about the individual atoms electronegativity. What is the electronegativity of fluorine? What is the electronegativity of chlorine or other elements in the periodic table? Let's see. So electronegativity generally increases across a period from left to right. When we move along a period, electronegativity increases, right? Electronegativity increases across a period when we move from left to right. You can see this. Electronegativity they have not mentioned in this diagram. They must have. Just wait a minute. Yes. See, electronegativity is increasing as we move along a period. Okay? Electronegativity is increasing. And when we go down the group, then what happens? Electronegativity decreases when we go down the group. When we go up the group, from below to up, electronegativity increases. Clear? In your periodic table, the previous pages I have shown you the periodic table. Yes, you can see here, as you go along a period, electronegativity increases, right? Fluorine is having maximum electronegativity. I have already told you that value is 4. For oxygen, it is 3.5. Okay. For nitrogen, it is 3. For carbon, it is 2.5 something. All right. And when you go down the group, electronegativity decreases. When you move along a period, electronegativity increases. This is the trend which you have to observe in case of electronegativity. All right, so you can see these trends. Table 3.8 shows electronegativity of period second elements and period third elements. Okay, lithium is having electronegativity 1, beryllium 1.5, boron 2, carbon 2.5, nitrogen 3, oxygen 3.5, fluorine 4. See, learning of these electronegativities is very easy for first period only. Okay, sorry, second period, because there is difference of just 0.5 in all. For electronegativity of third period, you can see sodium 0.9, magnesium 1.2, aluminium 1.5, silicon 1.8, phosphorus 2.1, sulfur 2.5, and chlorine 3. Okay, initially you people must have got that 0.3 ka difference hai, but later this difference increases after phosphorus to sulfur. The difference is of 0.4 and sulfur to chlorine the difference is of 0.5. So need not to make any hard and fast rule for the variation in the electronegativity, right? Now we can see but it is easily observable that along a period electronegativity value is increasing, right? And now we have to observe the electronegativity down the group. This is your first group: lithium, sodium, potassium, rubidium, cesium. You can see there is a continuous decrease in the electronegativity values, right? So along down the group electronegativity decreases. The same is the case with the seventh group. Seventh group is your halogens: 4, 3, 2.8, 2.5, and 2.2, right? For fluorine, chlorine, bromine, iodine, and astatine, respectively. This is all about the electronegativity, what we have to know. And let's summarize all the trends what we have studied till now. You can see we have discussed about atomic radius, the first thing. Okay, so atomic radius, when we move down the group atomic radius increases. When we move along a period atomic radius decreases. So you can see इन्होंने right to left बनाया हुआ है, that's why इनका atomic radius increase कर रहा है. Clear? Second is ionization enthalpy. Along a period ionization enthalpy increases. Down the group, what happens to ionization enthalpy? Down the group ionization enthalpy decreases, but up the group ionization enthalpy increases, right? Third, we have to discuss is electron gain enthalpy. Along a period electron gain enthalpy value increases, and down the group electron gain enthalpy value decreases, right? And the last what we have discussed is electronegativity. Electronegativity, up the group increases, down the group decreases, and along a period when we move from left to right, left to right, then electronegativity value increases, right? Right to left move करेंगे तो decrease कर जाएगा. Fine. This was all about the periodic trends in normal properties, physical properties. Now we have to see periodic trends in chemical properties. Okay. What are the periodic trends in chemical properties? Most of the trends in chemical properties of elements such as diagonal relationship, inert pair effect, underline all these points. Diagonal relationship, inert pair effect, and effect of lanthanoid contraction will be dealt with along the discussion of each group in later units. In this section, we shall study the periodicity of valence state shown by elements, valency state shown by elements, and anomalous properties of second period. इसके अलावा periodic trends हैं chemical properties के जो हमें देखने हैं, but वो हम लोग आगे पढ़ेंगे. For example, inert pair effect I will teach you in chemical bonding. Diagonal relationship I will teach you in chemical bonding. Lanthanoid contraction, effect of lanthanoid contraction when we will study the D block elements in class 12th. Okay, then I will tell you about this. So it is one of the most important chapter which is having your effects up to class 12th also, right? So please stay focused. Even not only this chapter, each and every chapter in chemistry is having some relation with the other chapters. So that's why I'm teaching you each and everything in a trend, in a series. Please don't skip any lecture. Okay, either take all lectures if you are an online student. Okay, either take all lectures of the series or don't take any. Don't waste your time. Okay, I don't want to increase your time. So by the way, periodic trends in chemical properties की हम बात कर रहे हैं, and this time what properties we are going to study is just first valency state or oxidation state you can say, and second the anomalous behavior of second period elements. Second period elements अलग सी प्रॉपर्टी शो करेंगे, सभी में एक्सेप्शन बनते चले जाएंगे. Why? क्योंकि वो सबसे छोटे हैं और उनमें कई सारे अलग अलग इफेक्ट देखेंगे. वी विल स्टडी इट इन डिटेल. ओके, so this is the time we are going to start our discussion for the periodicity of valency or oxidation states. Students, you know what is valency. Valency is the combining capacity of any element, right? Any atom of the element. Clear? And oxidation state is also more or less the same. For example, मैं आपको एक example दे करके इन दोनों में difference clear कर देता हूँ. Suppose you are having an atom of iron, okay? If it is having charge 2, you all know by your class 9th and 10th studies that iron is having variable valency. It can show valency 2 as well as valency 3. All right, by losing 2 electrons or by losing 3 electrons. Why it is so? Let me tell you that also, because I have already taught you the chapter structure of atom. You know that the valency of iron, atomic number of iron is 26 and the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 3d6. All right, this is the electronic configuration of iron in neutral state. Three, 4, 5, and this is your 6th. Students, ये बात तो आपको पता है that just to get the sequence in energy levels, we write 4s before earlier and we write 3d later. But what technically happens, 3d तो penultimate orbit है, बाहर का orbit तो 4s है. So कई बार ये भी सजेस्ट किया जाता है कि आप रीअरेंज करके इसे दोबारा से लिख दें और सारे एक एलिमेंट एक नंबर वाले एक साथ कर दिया करें, राइट? इट इज आल्सो सजेस्टेबल. ऑल राइट, सो 4s2 मैं बाद में बना देता हूँ. फाइन. नाउ व्हेन आयनाइजेशन एंथैल्पी यू ऑलरेडी हैव स्टडीड, राइट? और आयनाइजेशन एंथैल्पी हाई कब होगा? जब इलेक्ट्रॉन रिमूव होने से बहुत ज्यादा अनस्टेबिलिटी आ रही है, और अगर इलेक्ट्रॉन रिमूव होने से स्टेबिलिटी आ रही है, देन आयनाइजेशन एंथैल्पी विल बी लेस. If the ionization enthalpy value is less, then it is metal. If ionization enthalpy value is very high, then it is non-metal. Clear? तो जब आप फर्स्ट इलेक्ट्रॉन रिमूव करेंगे Fe से, Fe के एटम से, तो दैट विल बी इलेक्ट्रॉन ऑफ 4s2, राइट? 4s ऑर्बिटल. फर्स्ट इलेक्ट्रॉन आपने रिमूव किया, ओके. सेकंड इलेक्ट्रॉन तो बहुत आसानी से रिमूव हो जाएगा बिकॉज अब वो अनस्टेबल हो चुका है. सो इन जनरल आयरन शो 2+ वैलेंसी, राइट? And when iron is showing 2+ valency, in that particular point in time, these 2 electrons of 4s are removed, and now it is 4s0. 4s0 if it is iron 2+. Understood? Now iron 2+ में अगर आप नोटिस कर पा रहे हो तो there are 6 electrons in d orbital, and I have already told you, according to the Hund's rule of maximum multiplicity, the any orbital is stable when it is completely half filled or when it is completely full filled. Okay, so if one electron, this 6th electron of the 3d orbital will be removed, what will happen? It will become stable. So that's why iron is also having to lose even the 3rd electron to form Fe3+ atom, and to make its configuration 3d5, which is quite a stable configuration, right? That's why iron is having variable valency, first point. But this was not my point of discussion. My point of discussion was valency or oxidation state, right? So what is valency? Valency of Fe2+ is 2, the combining capacity is 2, and valency of Fe3+ is 3, right? But oxidation state is 2+. If you have noticed what different things I am speaking, valency is 2, but oxidation state is 2+. Oxidation state is always given with sign of the charge, okay? but valency is given without sign. Understood? So Fe3 plus is its oxidation state and 3 is its valency. Clear? Any doubt here? Fine. So let's move and discuss the trends in the valency or oxidation states in the periodic table. Yeah. So most fine. Periodicity of valency or oxidation states. The valency is the most characteristic property of elements and can be understood in terms of their electronic configurations. The valency of representative elements is usually, though not necessary, equal to the number of electrons in the outermost orbitals, or equal to the 8 minus number of outermost electrons as shown below, right?